So, hello guys, and welcome to this live stream. First, let me check if the live stream has started properly. Okay, I am unable to see any back on this. So, YouTube health is showing good. You recording stop streaming. Check here once. Coming scheduled. Stop streaming. Check here. Okay. The stream health is good, so we can continue with our main topic of discussion today. So, as you can see, I'm a specialist on code forces. I'm a second year ENTC student at VIT Pune. I have been doing competitive programming since last 22 months, since July of 2023. But I haven't made significant progress yet. Like I'm still a specialist, but in 2 years span, we could have done more. So a few weeks before, I just encountered a new training method in competitive programming, which was ThemeCP. As you can see in this blog by an international master font, I guess. I don't know how it is pronounced. So ThemeCP is a method to practice daily, give a contest daily on up in your particular rating range from -700 to +100, and it's I don't know, maybe he has done some data science, maybe he has used some analysis of past users or something, but he has designed this method based on that, and he got many positive reviews. So we will also implement this strategy. I'll be practicing competitive programming daily using this strategy. I will be doing a live stream daily, a daily 2-hour contest of 4 questions, which this ThemeCP method mentioned. You can check out the blog in detail. I will attach the link to the blog in my description, and they also have a website, you can check it out. I will also attach this link. Okay, so what is like ThemeCP? So ThemeCP is basically selecting 4 random problems in a rating range -700 to +100 of your current rating. My current rating is 1485. So +100 is like 1585, and -700 is 785. So I'll be practicing questions from those rating range. In fact, the ThemeCP sheet, if you go to the blog, there will be a attached Google spreadsheet. Yeah, here, begin your ThemeCP. The ThemeCP template can be found here. So this is the ThemeCP template. I don't think the first sheet is relevant. The second sheet is very important. From here, you have to identify your level. So my rating was 1485. I was a specialist. So the lower, I can see 1475 and 1500. So since my level was 1485, I can consider myself to be level 16, to be of level 16. And for level 16, they have told us to select 4 questions of these particular ratings. One question for 900, one 1100, one 1300, and the last one 1400. So I have to practice these 4 questions today. And how can I select the question? So there is also this valid topics sheet, but I'm not gonna select the topic from those. I have a plan of my own. I have to improve on some of these topics like binary search, bit manipulation, and two pointers and constructives. And since questions of rating is less than equal to 1000 don't have advanced algorithms or anything, so I will just practice constructive of those problems or ad hoc of those rating range. And from above, like one greater than 1000 rating, I will practice the binary search, two pointers, or whatever the theme was today. So basically today our theme is binary search. So I will select 4 questions of these particular levels: 900, 1100, 1300, and 1400. So these 3 questions will be of binary search, and the first question will be ad hoc or greedy. Now, how to select a problem which I don't know? So for that, we can use the code forces mashup feature. There is a create mashup feature. When you go to gym, there will be a button called create new mashup, and it is only available to the users who have at least given 3 contests and officially participated in 3 contests. So for this, I will name the contest as binary search 01. This is my theme CP. The duration of each theme CP should be 120 minutes, and I don't want to clone any existing contest. Now I will just create the mashup without adding any problems. So I have created a mashup, but it doesn't contain any problem yet. So now I'm going to add random problems, because it's no use if I'm solving problems which I already know. So I will click on add random problems, and I will exclude the problem created before 2020, because I don't think they are much relevant, because the contest format has changed quite a lot. And I will exclude problems already known by the user, like L1419GHT. So it will not give me any problem which I have solved in the past. And the problem requirement. So there is a particular format for this. Uh, I can select the letter of the problem, like problem A, problem B, problem C. I can select the rating range, and I can select the tags. I will just copy this particular format. I will paste it here. So I have to include 4 problems. The first problem will be A, second problem will be B, third C, and fourth D. And for the rating, 900, 1100, 1300, and 1400. Okay, so first one is 900. Okay, the first one is here. 900 to 900, 1100 to 1100, 1400 hyphen 1400, and the last one being 1400. Okay, and the tags I'm gonna change. For the 900 problem, I can keep it greedy, comma constructive, I guess. And for the rest, I will just keep it binary search. Binary search and binary search. Okay, so I will click on find problems button, and it is saying me constructive is unknown. Let me just check what is the full tag name for constructive. Yes, it is constructive algorithms. Okay, constructive algorithms. I will find the problems. Constructive algorithms. Yeah, I got it. I got 4 questions which satisfies the given conditions. Let's not dive deep into the tags, else we will have lost the purpose. I'm not gonna look at the tags. Now let's create a contest, add problems. So this is my contest which I'm gonna attend today. It's already 6:43 p.m. I will try to wrap it up within 2 hours, and if I'm unable to solve a particular question, I will have to solve it. So the strategy for theme CP is like select a theme, select 4 random questions of that particular rating range, solve the contest. Like how would you participate in any official code versus contest? You have to participate in it, and then if you are able to solve A and B but not able to solve C, then you have to decrease your level by 1. So currently I am on level 16. But if I am unable to solve all the questions, then I will move down to level 15. And if I am able to solve all the questions, I will move to the level 17, higher range. And higher range means more difficult questions. So currently I'm on level 16. So I don't know if uh, today I'll be moving to the next level or going back to the previous level. Let's see. So basically this helps you find the appropriate level, like the right difficulty for you, and you are training just in the right difficulty range, like which is not too easy for you and not too difficult, and maximizing the progress as the blog claims. Like I haven't, this is my first contest, so I don't know the results of this training, but yeah, they claim that it's really effective. So I will just edit some settings for this contest. Persons only. It allowed to solve contest problem unofficially. Yeah. And the start time, I'll have to put it something into the past because I am the creator of this contest. I won't be able to participate into it. Then I will just have a virtual participation. So for virtual participation, I have to 3 hours before 6:45. So I'll put it like 3 p.m. today. Today is 27th of Jan. Time 15:00. Okay, and let's not do anything else. Okay, contest has been updated and it has been finished. Now I can participate it in virtual contest. Okay. Also, I'll be adding the link to this contest in the YouTube description, and I have created a group for our college. So if anyone from our college VIT Pune is interested, you can access all the contest which I'll be doing daily into this particular group of VIT Pune. We'll share the link within VIT communities somehow, and you guys can have fun with the questions. Now let's close all of this. Uh, the website, problem set, contest. Also, I won't be using this particular ThemeCP sheet because the two important sheets, the level sheet and the sample tracker, I have used. I have copied them into my personal sheet. Like this is my personal sheet where I store all the important problems for revision and like notes and everything. So this is my particular sheet. Into this sheet, I have copied the level sheet and the sample tracker. So I will just clear this all. Clear this also. So this was the original ThemeCP. Like it has a template he has given. So I will first fill the template. Today is the date 27th of Jan. Yeah, right. Contest ThemeCP contest 01. Category binary search 01. And the level was 16 if I'm not wrong. Yeah, 16. So level 16. And the question were rated 900, 1100, 1500 and 1400. 16, 1100, 1300 and 1400. Okay, I will just close this sample sheet by them. Also, you can track your progress, like they have some graphs for insights. Mine will be empty since this is my first contest, but over a long period of time we can monitor our progress like this. Also, I will close this sheet now and get everything from here. So the basic method is whenever I solve a problem, I will have to come and I am able to solve it. I will write the penalty I got for solving that problem. So whenever I start the contest, for example, contest, we have a contest here. Just open it. Whenever you open the standings, I'll just open this friend standings here. Yeah. So for each question, you can see the penalty below. Like for like Dominator, the rank for here, you can see he got total cumulative of 7412 points. First question he solved like at 0 minutes, basically less than 60 seconds. The second question he solved in less than equal to 2 minutes. Third question less than equal to 5 minutes. Fourth question in 1 hour 58 minutes. And the points in green color show points for that particular problem. So we will just have to add this penalty. If we have solved a question, we will add that particular penalty. Like if I solved B and it took me 2 minutes, then I will add that 2 minutes to B here like that. And suppose if I solved T4 in 50 minutes, then I will add it here. Or suppose 110 minutes. Yeah, 120, 110 minutes. And if I have not solved T1, then I will just leave it blank. If I have not solved T3, I will just leave it blank. And this will give me the like predicted rating, like how I performed in this particular contest. Like in code forces you can see how did you perform. After each contest there is a rating change. And this sheet also has some formula, like they are also following some system. You can see the formula here. First I will change this particular thing to my actual rating. First click on this cell, P3 cell, and here 1411, this was my previous rating, now it is 1485. Just update it. And this is my first contest. And this rating was the rating before my first contest. I have to enter my code forces actual rating only once in this particular cell. The rest others will be filled automatically by a particular formula which will be dependent upon the performance of my contest in this sheet. So I have given only, like I have not given any contest yet, but after I give this particular contest, this will update. Like you can see, if I have would have solved this in 1 minute and this in 5 minutes, then this would have been like, and this in 50 minutes. Yeah, the rating changes good. And the performance, like how I performed in that particular contest, I performed as a 1671 rated coder, that is like a expert level performance. So, and here the sheet will show you some insights. So that was basically all about ThemeCP. So let's get started with our first contest. It's already 6:51. I predicted like it will take around some 20-25 minutes. So we are on the right track. Just close this. Uh, since we have some 4 minutes left from the quota, I'll just give you an intro about my setup. So this is my setup. I use VS Code and of course C++. Now this is my input window, this is my output window, and error logging window where I debug. I don't use a debugger or cout statements to debug. I use a template to debug, like it's a standard practice. And this particular template, you can find it on, maybe there was a blog on code forces. You can search debug template and you can find it. And this is my template for competitive programming. Let's go and start the virtual contest. Please switch off manager mode for mashup to register for virtual participation. Okay, I need to switch off the manager mode. Disable manager mode. Okay, let's take a deep breath before other contest. What virtual contest? The individual member virtual participation. Okay, we will start the contest in 1 minute. Okay, if you are trying to attend this contest live alongside me, don't forget your pen and book and other stuff. I always suggest having a book besides you if you are in a contest. Like I made the mistake of not using a book, pen, paper, and I could only solve till problem A. With only problem A, when they were easy, I could think them. But if they require mathematical equations or some derivation or some observation, pen and book always helps. Okay, guys, start it. If you are attending the contest, all the best to you. Also, the discussion for this contest will be in the end, maybe in the start. I will what fits better. Polycarp is preparing the first programming contest. Maybe I will turn off my mic for now. And once I'm done with the contest, I will have a post contest discussion. Hello, hello. Just check my mic. Hello, hello. Okay. I think my mic is working. Okay, so I think that's it for today's contest. Let's check the standings. Okay, so I solved in 10 minutes and be in like 40 minutes if I remember it right. And for the problem C and D, I think I got a general outline for D, but for C I don't know like what could have been done. Maybe I need to think more about it. I can give it just 30 more minutes. So let's start with the discussion. First, let's jump to the problem A and its solution. So the problem A was contest for robots. Polycarp is preparing for programming contest. So basically, what they have said is there are two robot manufacturing companies. The first is Robocoder and the second is the Bionic Solver. And what we want to do is we want the Robocoder company to always win all the contest. So as you can see in the input, there are the number of contests. There will be 5 contests, and we have given an array of zeros and ones. So whenever there is a 1 at a particular position, it means that that particular company, the first line here belongs to the Robocoder company, while the second line belongs to the Bionic Solver company. So first the Robocoder company, it means that Robocoder company can win contest number 1, contest 2, contest 3, but cannot win 4 and 5. And since second line denotes Bionic Solver company, it means that the Bionic Solver cannot win contest number 1, but it can win second, third, fourth, and fifth. Now, what we have to do is we can decide the points for each contest. Like we can decide the points for the first contest, second contest, third contest, and all are independent of each other. Like we can set points. If someone wins contest 1, they will get 100 points. If someone wins contest 2, they will get 500 points. And if both the companies can win the contest, then they both will get 500 points. But if only A can win, I will just say them A and B for now. If A can win the contest, only it will get the points, and if only B can win the contest, only it will get the points. And if both cannot get the points, then it will be 0,0. Like both will not get any additional points. Now what we have to do is we want the company A to win, or like the first array, we want company A to win, but we want to make the win such that the differences in points between A and B is as minimum as possible. So for that, we can first notice that if both the companies win or if both the companies has a loss, then it does not matter, because they both will be receiving similar number of points. So we can definitely ignore the contest where both are winning and both are losing, such that here the second contest, in the first test case you can see this second contest both are winning, and in the second test case you can see here like both are losing all the contests. So we can't do much over there because the results will be independent. But where there is a contest where either A can win or either B can win, what we can do is like whenever B is winning a contest, we can allot minimum points to him. Like if B is winning the contest number 4, then we will set the points to win contest number 4 is only 1. So whenever B wins a contest, he will get only 1 point. So basically here B can win 4 contests, but we will ignore the second and third because A also wins second and third. So the remaining contests are fourth and fifth. So B in total can get 2 points. Similarly, in the second test case, B can get here 0 points because he's not winning at all. In the third test case, since there is no such contest where only B wins, B can get only 0 point. And in the last test case, I think B can get 1, 2, 3, 4, 5, 6 points. Okay. So first we will have to calculate how many maximum points B can get. Now, since we have calculated how many points B can win, now we just have to calculate what points does A needs. Now, if A wants to win the overall championship, overall tournament, then in total A wants to score one more point than B. So suppose here, since B got 2 points, A want 2 plus 1 3 points. And in the second contest, here neither A nor B can win any contest, so it does not matter. Similar for third test case, but in fourth test case, A wants 6 plus 1 7 points. B has total of 6 points. A has to score at least 7 points to win the championship. Now we will have to only consider the matches where A wins to distribute the score, because if A and B both wins, then it won't affect the score and it will not result into a net gain or net decrease for A. So we'll count only such contest where only A wins, and we'll have to divide the total score among those contests. Like if A want to score 8 points and he wins, only he wins in two particular contests, then we will divide 8 into 4 and 4, so that the maximum value of P of I, they have said that we want the maximum value of P of I to be as minimum as possible. So we cannot keep like if A can win first and last contest, then we cannot keep like maximum points, total points of B plus 1 at first and the last at 0. We cannot do it in such a way, because the value will be greater and we want it to be minimum. So we will just divide, like if A wins 3 matches, then we will divide the total value by 3 and take the seal, because if there are 8 points and we have like 3 contests, we cannot divide it evenly. One extra will always remain, so we will always take the seal, because we have to score more, greater than equal to, we cannot score less than equal to. So for greater than equal to, we will take the seal and just output that. So it's the same thing that I have done in the solution. You can see first I'm taking the input array A, then I'm taking the input array B. While I'm taking the input array B, if A of I is equal to B of I, that means if both A and B wins that particular contest or both A and B loses that particular contest, we will not consider it, because it does not result into any gain or net decrease, and so we'll ignore them. So this particular line is for that. Next, I'm counting only the contest where B wins in a variable count B, and I'm counting only the contest where A wins in count A. Now if count A equal to 0 means if A is not winning any contest at all, that means A cannot win the championship because it's not winning a single contest. Therefore we will print minus, that it is not possible for A to win. But if it is possible, like A can win a single contest or greater than equal to one contest, then what score he will have to maintain? He will have to maintain a score of what B has scored plus 1. B has scored for the tie and B has scored plus 1 to win the tournament. Hence, count B plus 1 is our total score required by A. Now we have to minimize the score among all the contests, because if there is only one contest, then it does not matter, because we definitely want A to win. But if A is winning, and there are various ways to do that, we want value of individual P of I to be minimum, so we will divide them evenly, and this formula does that. Like I'm just taking the seal, I'm dividing the total score required by A, count B plus 1, and I'm taking it the seal of it with respect to count of A, like total number of contests won by A and total score required by A. I'm just taking the seal of it. You can use the seal function, but it is not like really recommended. Instead, you can use this mathematical formula, count B plus 1 plus count A minus 1 upon count A. It is similar to doing like what was it? Count B plus 1 and I'm taking the seal of it with respect to count A. And answer equal to seal. Yeah, this is right. So this is what I am doing. Count B plus 1 divided by count of A, and I'm taking the seal, and it can be represented in this way as well. I hope you understand the solution for A. Now we will move to the solution for B. Solution for B. So B was an interesting question. Like I needed a lot of time for that. First, basically, it's a question about a vending machine and lemonades. There are n slots in a vending machines, and at each slot there will be a particular number of lemonades, like soda cans, you can say, and all the spots are initially occupied with at least one lemonade in the slot machine. Now what we have to do is we can press a particular button, like if we press 1, then a single lemonade from slot number 1 will come out. If we press 2, a single lemonade from slot number 2 will come out. Now we can do process for uh, infinite number of times, but we need to find out the minimum number of button presses needed to be done so that we can receive at least k coins. So suppose we need to buy 10 lemonades, then we will have to go through the machine at least minimum of 10 times. If there are 10, like if there are 10 lemonades in a particular slot, we will press the button 10 times and we will get all the 10 lemonades. But the twist in the question is that we only know which we only know how many lemonades are stored in each slot, and we don't know the button for each slot. Like we can't like call I know the second slot, and the second slot has this many lemonades. Let's take an example, and I will move to the Excalibur. We will take this example 34213 Excalibur. Okay, so basically this is my slot machine. I have 3 slots in this. First slot contains 1 lemonade, second slot contains 2 lemonade, and third slot contains 3 lemonades. Let's shuffle the order. It's not too. Let's just say it's first slot contains 3, second slot contains 1 lemonade, and first slot contains 2 lemonades. Now, whenever we press a button, we can take a lemonade will come out from that particular slot, like but we don't know which slot it is. If I press 1, then a lemonade will drop from slot number 1. If I press 2, the lemonade will drop from slot number 2. If I press 3, the lemonade will drop from slot number 3. But the twist is in the question it's given that the initial slot contains AI cans of lemonade, but we don't know which button corresponds to which slot. So I don't know, one corresponds to this, one corresponds to this, or one corresponds to this. I don't know that. I don't know the order. So what could be my optimal strategy? First I went in a wrong direction, and I just thought like first I will take from the maximum, then I will take from second maximum. I will sort the array in non-decreasing order, so it will be sorted as 1 2 3. Then I will try to take the soda cans from the last one possible. Then like I will first take all the 3. If I am satisfied, like I got all the lemonades, then it's well and good. If I don't, I will just move to the next largest slot, then the next largest slot. I thought it could be done, but it was a wrong solution, because we don't know which slot number belongs to which block. So how could we approach this question is, we know that there is a minimum value that at all slots contains at least this much particular number of lemonades. Like we can see here, the minimum value is 1, means all slot contains at least 1 lemonades. So what we will do is take 1 from all the lemonades by clicking on all the buttons. So what will happen is this 312 will change to 2, 0 and 1. Now we will have, now we don't know if a particular slot has uh, been empty or not. Since we bought one from each of the slot, you know that there is a slot where there are zero lemonades, but we don't know which particular slot is that. So all like in competitive programming, always think that you are in the worst case, and since you are in the worst case, you are not in good luck. You won't get 2 in your next try, you will always get a 0. Like whenever you click on something, like if you want to account for the worst case, then account, just say that you have a very bad luck. And you can see that if you wanted 4 lemonades, first I took 111 from all. Now I want one more lemonade with minimum number of button press, but since my luck is very bad, I won't get that in the next one move. I will have to spend 2 moves. First I will click on the second slot, and then I will get to know that the second slot is empty. Then I will never press the second slot again, and I will check for the remaining 2. Now just check for the other remaining number. Like after removing 1 from each of these, there are now 2, 0 and 1. And since I have pressed one more time to verify that yeah, not to verify, just because of my bad luck, I got to know that this particular slot is empty, so I will never press it again. Now we know there are only 2 slots left in machine that contains lemonades, and the minimum of those would be what each of the slots will contain. Now the minimum is 1, and we know that every slot will contain at least 1. And since because we are always considering the minimum, whenever you remove the minimum element, all the remaining slots will contain at least greater than equal to the remaining element number of lemonades. So now we have been left with 2 and 1, and we have spent a total of 4 moves. In the initial round we spent 3 moves for each one of them, and then since the middle one became empty, we had to press one more time, so we could account for we could check that that particular slot is empty. Now we want one more number of lemonades. Suppose we want 4, then I will press any random button other than the second, because second has become 0. I will press 1 or 3. I will definitely get 1 lemon soda. Then if I pressed on 2, then the array could have become 1 comma 1. But if I would have pressed on 1, then the array could have become 2 comma 0. And if the array has become 2 comma 0, then suppose now I have got I have got 4 sodas, but I wanted 5. Then what should I do? What should be my best strategy? So suppose if I clicked on 2, then there is 1 remaining, then we can again click on 2. But why do that when we definitely know that the other slot will definitely contain at least 1? You can see the remaining numbers are 2 and 1, and the minimum here is 1, so we definitely know that each slot contains at least 1 lemonade. So instead of clicking on one particular slot multiple times, we will click through all the slots for that minimum number of times. Here it is 1, so we'll click through all the slots for 2 times. If the sequence would have been something different, like 5 comma 3, then the process would have been different. If it was 5 comma 3, then I know that a particular first slot contains 5 lemonades and the second slot contains 3 lemonades. Now I can either keep on clicking on the first slot and get 5 elements, or either I can keep on clicking on the second slot and get 3 lemonades. But in the first case, when I click on first slot for the 6th time, I will find that it is empty, and I will waste a single move, and the total number of lemonades I could have got for 6 moves would be 5. And in the second case, if I would have clicked on the second slot for 4 times, then the total number of lemonades I could have got for 4 moves would have been 3. But if I definitely know that each slot contains at least 3 elements, since 3 is the minimum, then I will click 3 times on the first slot, 3 times on the second slot, and I will get a total of 6 lemonades for 6 moves. And this can be proven that it is the efficient and most optimum strategy for finding lemonades with guarantee. Now we will just have to implement it in code, which can be done like through a priority queue, and we can, if we could optimize the priority queue, then it will turn into a linear solution with an array. So first we need to find the minimum element. In this particular array, the minimum element is 1. In this particular element, the array, the minimum element is 3. Once we have found the minimum element, then we will subtract that minimum element value from all the elements. Suppose the array was like this: 5, 3, 7, 8, 9. Now here the minimum element is 3. So I can press 3 times on every slot and I will get a total of 5 3s are 15 lemonades. For example, 5 will become 2, 3 will become 0, 7 will become 4, 8 will become 5, and 9 will become 6. Now I will have this many number of lemonades in their corresponding slots. So now here we have 2, 0, 4, 5, 6, and we will just drop out the 0 because we have used it completely. But after completing this target, if we have satisfied the number of lemonades we found, then it's well and good. And if we have not found the number of lemonades, then we will have to press one more time in this slot to find if any more lemonades are remaining is in this slot. If they are not remaining, then we will just pop back and increase our button press count by 1. And else, if we have completed the target, then we will just print the button presses required. So building upon this strategy, now we have 2, 0, 4, 5, 6. If we have already found the k lemonades, then we will just exit by printing yes. But if we haven't found, we will just continue the process with remaining ones. Now we have 4 slots left, and among the 4 slots, I know that at all lemonades slots contain at least 2 lemonades. So I will subtract 2 from all of them. So the array will become 0, 2, 3, and 4. Now this is my this is the state of my array, and what would be my, like, here I got total 15 lemonades, and here I got 4 to the 8, and 15 plus 8 is 23. Now I have a total of 23 lemonades. If my required k is less than equal to 23, I will just exit and say that I have gotten my desired lemonades in this many required number of button presses. Else if I have not found, then first I will have to remove this 0. For that I will need one more button press. So I will increment the button press count by 1, and now we have another array 2, 3, 4, and I know that all the slots contains at least 2 lemonades. So I will continue with the process. I will subtract 2 from each one of them. Now I will have 0, I will have 1, and I will have 4 minus 2, that is 2. Okay, so now we have 0, 1, 2. And what number of lemonades can I get from this state to this state? I could get a total of 6 lemonades. 6 would be 2 from each slot, and there are a total of 3 slots. So 2 times 3 is 6, and 23 plus 6 would be I'll just keep it in sequence. It was 23, and 23 plus 6, it is 29. Start it over here. Now we have 29 lemonades, and we have this state of the array. And if 29 is sufficient, then we will just exit with yes, else we can continue this process. Now we have to implement it using an array, because I tried the priority queue solution and it didn't pass the test cases. I think it got a TLE. Yeah, the priority queue solution got a TLE on the 10 test case, so I had to optimize it. Okay, I will just go to my submission for B. Let's go to my priority queue solution also, and the normal array solution as well. First, let me take you through the priority queue solution because it is easier to understand. So I'm building a priority queue. The top element of this priority queue always provides me the minimum element of the priority queue. This is the syntax for that particular providing the minimum element, and for the maximum you can just declare priority queue int comma pq. And since I needed the minimum element, I need to write this extra syntax. Now I am taking all the elements into a priority queue. Then I am searching for answer via binary search. The constraints on this problem were very low, like only 1 second. So I had to find less than linear, because the priority queue takes log n, and if log n and log n int n comma k would file priority queue vectors moves with okay, huh? The priority queue solution will become n log n, because the priority queue operations are in log n times. Suppose you are doing a push or you are erasing an element from top, all these operations are of log n, and we are doing this operation for total n elements, and the complexity here will be n log n. And with that we will have an additional time complexity of binary search that would be around log n. So the total time complexity was n log n into log n. uh, and this code like didn't pass it, so I had to convert it from n log n into log n to just log n, n log n. How I did it was I turned this priority queue solution into an array solution. The logic was exactly the same. First, let's discuss the binary search approach, like why I was doing a binary search. Here you can see I have written a binary search, and it can be seen in the priority queue solution as well. Yeah, this is the array solution. I'm doing the same binary search with the same check function, sufficient function, and here also I have used the same sufficient function, and I'm doing the same binary search. Now the logic for binary search comes from, like, if I can get k eliminates for suppose 100 button presses, then I can definitely get k eliminates by 200 presses or greater than that. And if I cannot get a lemonade for 50 button presses, then I will also not be able to get k lemonades in less than 50 presses, so like less than 50 button presses. Hence we can say that the number of lemonades which we can buy is a monotonic function of the number of button presses. Hence we can do binary search for the amount of button presses we are doing, and for each amount of button presses we will check if it is possible to buy k lemonades. So I'm doing exactly that. I'm searching for the amount of button presses, low equal to 0, high equal to infinite. So I'm saying my total number of button presses could be 0, it could be infinite, like 10 to the power 18, and I'm storing the amount of button presses, minimum amount of button presses, in an answer variable. Whenever I can buy k lemonades using a particular number of button presses, suppose mid, here mid denotes the number of button presses. So if I can buy k lemonades from mid number of button presses, then I am storing the answer equal to mid. And since it is monotonic, answer will always tends to be lower. Suppose initially answer I got an answer of for 0 to 200 I got an answer of 100. Now since the binary space search space has been halved, the next answer will always be less than 100, that would be 50, and it cannot be greater than that. Hence I am not doing answer equal to min of answer comma mid, I am just doing answer equal to mid if sufficient of mid comma pq comma q. And this function just helps me find that in mid number of button presses can I buy k lemonades, and if I'm able to buy that, answer is equal to mid, else I'm just improving my search space accordingly. And here in the sufficient function, I'm first finding the minimum element of the whole priority queue, and I'm subtracting that minimum element from all slots. So the total number of elements, like total number of slots is sz here, and minimum number of slots in each slot is ELE element PQ dot top minus order dot minus, and the total number of laminates I can get at that particular state would be the total number of slots left into the minimum laminates in a slot. And if that particular count is greater than equal to k, that means greater than equal to required, I will just return true, and else I will just return false because I don't have the enough moves. Else the value is lower than that, because it can, in the future step it can increase, but at the current step it has not been sufficient. Then I will just subtract that many elements from my required k. Like currently if I'm getting 8 lemonades from the current point, then I will just take all those 8 lemonades, I will subtract 8 from my moves, and I will subtract 8 from the k. But also I need to find the current slot machine has been completely finished. For that I will need to spend one extra move, which is denoted here. And if moves is less than equal to total required lemonades, then I will just return false. And after each iteration I will just pop the minimum element of the cube. With this way we can find the minimum number of lemonades which we can get, like minimum number of button presses required. This was a priority key solution which got a TLE. Then I simply used the vector. I sorted the vector. First I took the input in my vector, then I sorted the vector. After sorting the vector, I did the same binary search approach on this vector. I just modified my formula a bit, which will work with this vector. And instead of popping the minimum element, since the vector is always sorted, I know that a array of 0 is always the smallest, and if I pop ARR of 0, then ARR of 1 will be the next smallest. If I pop ARR of 1, then ARR of 2 will be the next smallest. And since this sequence goes on, I can just iterate from I equal to 1 till I is less than the size of the slots, like total number of slots. And I will continue to update the available and required k values. And if I am at any point able to buy k lemonades, I will return true. And till the end of the vector, if I am not able to buy that many required lemonades, then I will just return false. And this function works on that. And as you can see, it successfully got accepted. As for the problem C, I couldn't get a hint or logic on how to do that. Maybe I will try to solve it. For problem D, I got the logic, like I figured out the logic on how we can approach the question. So first let me start by explaining the question to you. We have a string database, like we have a password database. The input is, first we will get a password database or a string, then we will get integer n. Here it is 2. That means we have to create a n digit password, and for each of the digit of that password, now here we need to form a 2-digit password. And we have been given 2 arrays. These 2 arrays correspondingly tells us the lower limit and the upper limit for each digit. For example, in the first example, we have, for the first digit we have been given the lower limit of 5 and the upper limit of 5. That means the first digit of our password has to lie between 5 and 5. For the second digit, the restriction is 0 to 6. That means the second digit should lie between 0 and 6 inclusively. So I will just copy this test case. I'll paste it into Excalibur and delete everything. Now the total number of passwords which I can make through this would be, the first letter would be always be fixed, the second can be 0, it can be 1, it can be 2, it can be 3, 4, 5 and 6. These are all the passwords I can make with the given constraints. Now you will ask, what does this first string denotes? Now we have to find out of all these combinations of these many passwords, it could be extended as well. Like if this was 3 and this could have been 0 and this could have been 9, there will be too many combinations, so I will not dive into that. I will just say this is 9, and this is also 9. Then we will just have to add a single 9 to the end of each of these. 9 everywhere. Now we know all the possible combinations which we can make from the given strings. We have to tell whether it is possible to form a string in such a way that it does not occur in the given string as a subsequence. So suppose let's take 5, 0 and 9. Does 509 occurs in this given string as a subsequence? We'll check 5. There is no 0 which lies after 5, so there is no issue. Like we can form a string which does not comes as a subsequence in uh, the given string. Uh, but if the string we could have chosen was something like this, if we would have been given this string 9 and we were trying to form this string 519, then we can see that 5 here exists, 1 here exists, and 9 here exists. So it is not possible to form a password 519 because it occurs as a subsequence in the original string. Now for over all the combinations, we have to report if there is a possibility to generate a password which does not comes as a subsequence in the original string. If we see the constraints of the question, uh, the length of the required password is 10, and means there will be at max 10 digits in the password, and each digit can go from 0 to 9. And since the constraints are small, we can go the brute force way of finding maybe not, yeah, no, maybe not, because since the but although the constraints are small, we can only have a array of size 10, but each slot can have 10 different values, and that would be around 10 to the power 10 is 1 10 total different number of possible combinations. And we cannot store or process that many number of combinations, so we will have to think smart. And I tried to find a way around this, like we can use a greedy strategy here. Like since we don't want our password to come as a substring in the original string, then suppose if our first element is 5, then from the string we will always take the element with the rightmost occurrence. Suppose here I can let's ignore the first digit for now. We'll work our way through the second digit. Like at the second digit we have the possible options of choosing 0, 1, 2, 3, 4, 5 and 6. But what should we choose and what will be beneficial to us? For something to be beneficial for us, we want our string to become empty as soon as possible. Like if the first number comes here, like our first digit comes occurrence comes here, and the second digit occurrence comes here, then the remaining numbers will just go outside the string and they won't exist at all. But if our first number occurs at the leftmost side and second number occurs at the second leftmost side and so on, then our entire password will come as a subsequence in the original string. Hence, to avoid that, we will always try to take the element which has the rightmost position in the given string. So suppose here first element only we have only one option, so we'll just take 5. But here we have total 7 options. For 7 options, for 0 we have the position 4. I will just note it down. For 0 we have position 4. For 1 we have position, I don't know, let me count, 1, 2, 2, 3, 4, 10, 11, 12. So 0 has a position of, okay, and for the remaining ones it is just below the digit, particular things that fit it. 12, 13, 14, 15, 16, 17, 18. Okay, so now we have the positions of all the digits. The rightmost one exists at position number 12. Then for 2, 3, 4, 5, 6, 7, we'll try to find the rightmost occurrence of these numbers. For 2, the rightmost occurrence is of 13. I will just note it down. 13. For 3, the rightmost occurrence is 14. For 4, the rightmost occurrence is 15. For 5, the rightmost occurrence is 16. For 6, the rightmost occurrence is 17. And for 7, the rightmost occurrence does not exist at all. E, N, E. So, as we can see, uh, the rightmost occurrence for each number is as shown below. It is always beneficial to select a number which occurs at the rightmost points, because if we take the rightmost, then we will have minimum numbers left uh, to come as a part of a subsequence from the given password. And if a number does not exist at all in the string after a particular point, then we are good to go. Yes, we will be good to go that way. But the range for our search, it will vary. Suppose we have to we have taken the 13th like we have come to the 13th position at the original, like the given string, then we will have to search for the rightmost position just after this position in the given string. We won't search in the left part, we will only search for the right part. And if we have selected suppose 4 from here, then we will only search for the next index from this part, and hence our search space will keep on getting smaller and smaller, and we will just have to find for the rightmost occurrence in the remaining search space. And if a number does not exist at all till the end, like here we can see that 7 does not exist at all, then it is possible to form a string which does not come as a subsequence. But if a number comes up, even though it is at the rightmost part, but if it still comes up, then it's not possible to form a string. And that's the logic for the question D. I was still coding it, but I couldn't finish the implementation before the contest ended. Maybe I will try to absolve it as well. Now that's all for today, guys. If you are also interested in attempting this contest, I will share the link to this contest in the description. You can give a virtual contest. I will be doing live streams daily from today. Maybe in a few months time we will see what this ThemeCP, will this ThemeCP really help us at all or not. But I think it will definitely help me become more consistent. And maybe if you guys start doing it, you guys can gain consistency as well, if you have problem with consistency, like. So that's all for today, guys. Thank you, and have a nice day.